Welcome back to Galaxy Stories. Today, let's embark on a breathtaking visual journey through space and time, exploring the deepest mysteries of our universe. We begin in intergalactic space, billions upon billions of kilometers from Earth. Here, we float in the vast emptiness between two colossal neighbors, our own Milky Way galaxy and the majestic Andromeda galaxy, each containing hundreds of billions of stars dotted around us. Space seems almost perfectly empty, yet we are not. Nowhere. Massive cosmic web surrounds us, the structure of the universe itself. This web, made of space-time, acts like an invisible grid. Through this grid, we can visualize the unseen geometry and the hidden forces that govern the universe from our position. The grid appears calm, still, and undisturbed. If we throw a marble, it would glide endlessly into the darkness, never slowing down. But this stillness is an illusion. If we fast forward time, space-time begins to drift gently, like a slow-moving river. Stars, gas clouds, and dark matter tug at this cosmic fabric, pulling the grid toward them and slowly shifting the entire structure. Because of this gravitational dance, the Milky Way and Andromeda inch closer every moment. In a few billion years, long after humanity is gone, these two giant galaxies will merge into one colossal system. But while Andromeda approaches us, astronomers in the early 20th century made a stunning discovery. Most galaxies are moving away. The universe is expanding, stretching like a vast cosmic fabric. As space-time expands, galaxies drift apart, and their light becomes stretched, turning red. This is known as redshift. Today, we know this expansion is accelerating, powered by a mysterious force we call dark energy. This expansion began 13.8 billion years ago, when the universe was compressed into a tiny, hot, chaotic state, filled with fluctuating energy. Then, almost instantly, the universe expanded to unimaginable size. This event is known as the Big Bang. What existed before it? No one truly knows. Tiny quantum ripples eventually grew into immense structures, pulling matter into filaments and halos, forming galaxies, stars, and ultimately, Earth. Today, we live near one of these countless stars, our sun, around the sun orbit planets, asteroids, and comets, all moving freely within the grid of the universe. The sun's enormous mass curves space-time, causing the cosmic fabric to fall toward it, pulling everything into stable orbits. Planets move straight ahead, but space-time itself bends their path back toward the sun. Similarly, Earth curves space-time around itself, holding the moon and thousands of satellites in orbit. The International Space Station travels straight, but the curved space-time beneath it keeps it from flying away, far from Earth. The grid flows gently, and an object moving fast enough can escape easily, but closer to the center. The flow becomes denser and faster. This is why rockets must reach incredible speeds to escape Earth's gravitational pull. If we drop several apples close together, space-time pulls them inward in one direction and stretches them apart in the other. These are tidal forces, the same forces the moon uses to move Earth's oceans, creating the tides. Earth spins once every 24 hours, and this rotation slightly drags space-time with it. Even a falling apple experiences this tiny influence, shifting its path ever so slightly deep inside the Earth. The grid continues its inward collapse, but Earth's materials resist this pressure, pushing outward to prevent the planet from collapsing. This resistance is what we feel when we hit the ground after a jump. If a marble could survive the crushing pressure at Earth's core, it would rest motionless at the very center.